Now I will explain about the Millikan's experiment to determine the charge on the electron. In the Millikan experiment, we have two plates, metal plates with a small hole on the top plate. By using an atomizer, we can spray oil here, oil drops. This is a oil drop. So an oil drop is formed between the region between the two plates. The two plates will be insulated and there will be covered with the glass here. So the oil drop can be allowed to fall by its own weight without applying the electric field. So first what we do is here we by the using an atomizer we produce oil drop and allow the oil drop to go between the two plates under its own weight. This is known as motion under gravity. Then we send powerful X-rays here. We send powerful X-rays into this region. The gas or air here gets ionized. That means some electrons are removed from the neutral molecule of the gas. The oil drops may pick up few electrons. It may pick up 2 electron, 5 electron, 10 electron, any number, and it becomes a charged oil drop. Now we switch on the electric field. That means upper plate is made positive and lower plate negative by giving a potential difference. So now the negatively charged oil drop experience upward force, it will start moving upward. So that is motion under electric field. In both cases, the terminal velocity is calculated. Okay. Now let us say first motion under gravity. Motion under gravity. That is the drop is moving down by its own weight. So what is the net downward force? Net downward force on the oil drop equal to viscous force, then only terminal velocity will be reached. Net downward force is 4 by 3 pi r cube rho minus sigma g, where rho is the density of oil, sigma is density of air. That is equal to 6 pi eta r v, where v is the terminal velocity. So this is the first part. Second part, motion under electric field. Motion under electric field. So now net upward force will be QE minus 4 by 3 pi r cube rho minus sigma g. The charge on this drop becomes Q, negative, so QE, upward force, that is equal to 6 pi eta r some v dash. Now this will be a different terminal velocity. So first we make the drop come down by its own weight, and ultimately it attains the terminal velocity. The motion of the oil drop is observed through a powerful microscope, and there will be readings in the field of view, and we can use a stop clock to find the time taken to cross between two lines there, and from that we can find the terminal velocity. Okay. So this is the second part of the experiment. Now add these two. When you add these two, this gets cancelled. So we get QE equal to 6 pi eta r v plus v dash. So Q will be equal to 6 pi eta r v plus v dash by E, and Q equal to Ne, where N is the number of electrons it has picked up. So Millikan performed experiment and he studied lot of oil drops, and he found out that the charge on the oil drops are in the integral multiple of this quantity, and he found out E to be 1.6 10 power minus 19 coulomb charge on the electron. So Millikan oil drop method, problems based on Millikan oil drop method means you have to see the following factors, that is it is moving under gravity or it is moving under electric field, and the density of air is much less than the density of the oil drop. We can omit the upthrust because sigma is very small. 4 by 3 pi r cube rho minus sigma we can now take as 4 by 3 pi r cube rho g. Okay. So the following problem we will discuss, we will apply this principle.